Okay, welcome viewers. So in this video lecture, we want to solve some recurrent solution where you are also given the boundary conditions. Okay. So for example, question is this: solve an an minus 1 minus 2 times an minus 2 equal to 0 with these conditions that a naught equal to 2 and a1 equal to 7. Okay, so whenever you are given these boundary conditions, in that case you need to find the values of the constant also after finding the solution. Okay, so solution, what is its order? Okay, see its order is n minus 2, so it is 2. Okay, so therefore characteristic equation is alpha square minus alpha minus 2 equal to 3. So now factorize it: minus 2 alpha plus alpha minus 2 equal to 0. Now take alpha common, alpha into alpha minus 2. Take 1 common, alpha minus 2 equal to 0. Alpha plus 1 and alpha minus 2 equal to 0. Okay. So what are the roots in this case? Okay. So the roots are alpha equal to minus 1 and okay. So what is the solution in this case? Solution is C1 minus 1 raised to the power n, C2 2 raised to the power. So this is the solution. Okay. Now we apply the first boundary condition given that a naught equal to, okay, means set the n value equal to 0 in this first equation. Okay, so it is n0 a0 c1 minus 1 raised to the power 0 plus c2 2 raised to the power. Okay. So what is the a naught value? It is 2, and anything raised to the power 0, that is always equal to 1. So c1 plus c2 equal to 2. Okay, so from here we can find the value of c1. So c1 value is 2 minus, write it as equation. Okay, apply the next condition that a1 equal to 7. So set n value equal to 1 in equation. So it is a1 c1 into minus 1 plus c2 into, okay, because here the n value, what is a1 value? 7 minus c1 plus 2, so 7 minus, what is c1? 2 minus plus 2c, 7 equal to minus 2 plus c plus 2c, so it is 9 equal to 3c. So the value of c2 is what? The value of c2 is 3. If the value of c2 is 3, now use this value in equation number 2. So from get c1 equal to 2 minus 3 equal to, okay. So after finding the values of c1 and c2, you just put this value in equation number 1. Okay. So this is our equation number 1, and in this we want to substitute the value of c1 and, okay. So an is c1 value is minus, it is minus minus 1 to the power n, and c2 value it is 3 times 2 raised up. So this gives me the solution of the problem. Okay. Now after this question, we just solve one more example to check that how to solve these types of question. Okay. So see one more example. So the question is this: that solve an minus 6 an minus plus 9 an minus 2 equal to A naught equal to 1 and A1 equal to 6. Okay. So what is its order? Its order is n minus n minus 2 raised to. So its characteristic its characteristic equation is alpha square 6 alpha plus 9 equal to 0. It is alpha square alpha alpha plus 9 equal to 0. So take alpha common, alpha minus 3, take minus common, alpha minus 3, alpha minus 3 and alpha minus 3 equal to 0. What are the values of alpha? They are okay. So as the values of alpha are 3 and 3 mean, here we have repeated roots. So the what is the solution? Solution is C1 plus C2n into 3 raised to the power. Okay. Now set n value equal to 0. So when n is 0, what it is? It is A0, C1, C2 into 0. It means C2, 3 raised to the power. Now what is the value of A0? And anything raised to the power 0 is 1. C2 into 0 is 0. So value of C1 is okay. Now set next n value equal to okay. Set n value equal to so this equation becomes A1 equal to plus C2 okay, 2 okay, because the n value it is equal to 1. And what is the A1 value? A1 value is 6. Okay. The A1 value it is 6. And so it is 3C1 plus 3C2. But you see here that the C1 value is also 1. So 6 is equal to 3 plus 3C2. So 3 is equal to 3C. So C2 it is now after finding the values of C1 and C2, use these values in equation. Therefore, from 1 we get An equal to C1 is 1. Okay. So 1 plus n C2 is also 1 into 3 raised to the power. This is the solution of the recurrence relation. Okay. So more about it will be discussed in the next